Hello everyone. We are about to talk about production possibilities curve. So today you're going to learn what a production possibilities curve represents. And this is a graphical way, a way of drawing that shows opportunity cost. So if you think about a pair of trade-offs that you might face, we've got a list of opportunities and options here, but I'm going to go with teacher planning a lesson. I could plan a part of my lesson where I'm talking, or during that time I could have you work on a worksheet. So my opportunity cost of talking to you would be letting you work on a worksheet. When you have a pair of trade-offs, the thing that you choose to do is what you choose, and the other thing is what you give up, or your opportunity cost. So a production possibilities curve is a model that shows the trade-offs or opportunity cost between two options. So this is going to be a graph, and we're going to draw it out as such. I'm going to show you how to construct a production possibilities curve, and from here on out I'm probably going to call it a PPC, which is the shortened version of production possibilities curve. So let's talk about what it would look like at Dairy Queen. Let's say it's a hot August afternoon and Mr. Ronnie's looking at his food prep workers. He's got 6, and he's trying to decide whether they should be making blizzards or burgers. So he can either put those workers at the blizzard machine or the burger machine. And if you think about it, there are times where each choice is going to have more value. In August, right after school, he's probably going to need more workers making blizzards. In January at lunchtime, he's probably going to want more workers making burgers. And right after football practice lets out in August, he might have the workers split. So there are all kinds of choices along this curve. And what we're trying to do is map all of the possible choices that exist. So here I'm going to take a look with my Dairy Queen employees. And if I've got 6, I'm going to move them over here to burgers. So if I put all 6 of my back of house employees on the grill and they're making burgers, the maximum number of burgers they can make is going to go on my graph. So here's a PPC, and as you can see, I've labeled one axis burgers and I've labeled one axis blizzards. So if I put everybody on the burgers, all 6 employees, I can make 100 burgers. So that's going to be this top dot, and this is where I'm going to start to draw my production possibilities curve. Then as I move one worker over to blizzards, I give up. That's opportunity cost every time we say give up. 10 burgers, but I gain 30 blizzards. Then when I move this worker over, I give up 20 more burgers. That's a marginal cost, right? Because just moving one, I give up 20 more burgers, 30 burgers total, and I gain 20 blizzards. So my marginal benefit would be 20 blizzards for 50 blizzards total. Then as I move my other workers over, notice I didn't graph everything out because I didn't want to junk up my graph with too many points. Also, I had a really hard time drawing that curve, so forgive me a little bit. But as you notice, as I move all the way to 6 employees around the blizzard machine, this machine's getting pretty crowded. So what I have is increasing cost in blizzards. As I move these last workers, I give up a lot of burgers because even one employee on the grill can make a lot of burgers. And I only gain just a little bit of blizzards. So my last employee, assuming this point represents them, would give up 40 burgers on the grill and would only gain 10 blizzards. So this is the point where with all 6 employees, I can make 80 blizzards max. So I'll put a little point here. Couple of points I want to make about the PPC. One thing is that because my resources don't adapt equally, so if I had 2 grills and I can move them from making burgers to hot dogs, my grill is going to work just fine either way. So the resources would adapt equally and this PPC would be a straight line. But because the blizzard machine doesn't help me make burgers and the burger machine doesn't help me make blizzards, and also because the resource starts to get crowded as I add more and more employees, this doesn't have a straight line. It is curved. So I give up different amounts of burgers. When I take this first employee off the blizzard machine, my opportunity cost is only 10 blizzards, but I gain a lot of burgers because she's over here working and she doesn't have anybody in her way and she can do really well. When I add this second employee, my marginal benefit, my gain from adding one more, is 30 burgers. So the help, which means I have 70 burgers total being made with these two employees. But I give up 20 blizzards because maybe this person was preparing the cups and it helped out. So opportunity costs can change and aren't one-to-one. It's not like I give up 10 burgers, gain 10 blizzards, give up 10 blizzards, gain 10 burgers. It changes as I move along the PPC, and that's why this PPC is curved. If it was the same, say 2 hot dogs for 1 burger every single time, the PPC would be a straight line. So to review, the basics about a PPC are that it shows opportunity costs. So you have to narrow it down to 2 items, the one you're making and the one you most likely would make instead, or the one that you'll move another employee to. And you create your PPC by mapping the maximum amount you make if everybody's working as hard on burgers as they possibly can, or everyone's working as hard on blizzards as they possibly can. Then if you plot out where you move folks, or if I'm having you draw one for class, you just connect your dots with a curved line, you'll have your PPC. So let's talk about what PPC is. Again, it stands for production, meaning things that you make, possibilities, meaning your options. So you could produce here with everyone at the burger machine, or you could produce at any line along, any point along this line. Okay, so if everybody's working as hard as they can, your production possibilities are defined by this line. Now, tomorrow we're going to talk about what happens when people aren't working quite as hard as they can and what that's going to mean, and also when you're asked to do more than you can possibly do. So a quick question to answer here is, what is the opportunity cost of moving from point A to point B? First thing you want to notice is opportunity cost is what you give up. So what I've done here, when I moved from point A to point B, I've moved some workers that were making hamburgers to making blizzards. So I've gained some blizzards and I've given up some hamburgers. So to figure out my opportunity cost, I'm just going to take the 90 hamburgers I was making and subtract the 40 hamburgers I'm still making to find the distance between these 2 points, and that would be 50 hamburgers. Then if I decided to move a worker from point B to point A, I'm going to take the 40 hamburgers that I was making and the 70 blizzards I was making. Now I'm making 90 hamburgers, but my opportunity cost was that I gave up 40 blizzards, the distance between 70 and 30. We are going to go over this. We're going to practice some problems with this. So don't panic. We're going to work together on this if you're having trouble grabbing it. And if you're not having trouble grabbing it, no problem. That is awesome. One thing I do want you to understand about economics is we talk about lots of different types of concepts in this course. It's a survey course, so we're sort of all over the place trying to show you all kinds of different types of economics. So if you get something real easy here, you may have your turn a little later in class where you struggle. And if you're struggling with this right here, don't worry. You'll have a chance to be the expert and grab it first later in the course. So there's lots of different types of learning going on here.